Wow. What day? During the day or after the day? What time? And is it in the Mac? In like Pierce's Mac, basically?
One person just does all their lists.
It's like everybody does.
Yeah, one at a time. So they can typically, yeah.
Okay, here we go. And we'll watch him in class together. Okay. Okay.
The regular game for us is 7 innings.
Yeah.
We went 13 innings.
Because y'all kept tying it or what?
We got, I think, 4 hours long.
That's great. What school was it against?
It's at like 11.
It was like y'all were both just really trying to not lose.
Terrible.
That sounds. Oh no! After that many innings,
No, it's not.
that's crazy.
13.
That is great for them. Like you start. Really inspires.
You don't get full unless you're a pitcher. You don't get full.
All right.
But most of the other pitchers don't.
Okay. So y'all, we're gonna learn what an antiderivative is today. So if we could put computers away, y'all should have some time to work on your homework. And then if you want to pull those back out, that would be fine. So for an antiderivative, let's start with derivatives. Because remember, we're just reversing that process. So if I have f, what do I call the derivative of that? F prime, what's the derivative of that? Okay, and then if I took the derivative again, f triple prime, blah, blah, blah. Okay, so derivatives, you're going to go down that list. Well, then for an antiderivative, you're just going to go basically up that list. Okay, so on this side, I'm going to go up and I'm going to put antiderivative. So here's what I mean by that. Read right here. It says the antiderivative of f double prime. That means I would be undoing one of the derivatives off of f double prime. That would put me at what? F prime. And then if I do the antiderivative of f prime, I'm undoing one of the derivatives. That would put me back at what? Regular f. Now, if you do an antiderivative on regular f, you're going to get capital F. And so I want you to now add that to your list. Capital F would be the very top of the list. Okay. So if I want an antiderivative on regular f, it would go to capital F. Okay. Now, capital F is the antiderivative of little f if the integral of f of x dx equals capital F. Okay, the symbol that you just drew, okay, this is an integral symbol. Okay, and so if you ever hear this called integration, antiderivative, they're the same thing. Okay, so I'll put integral symbol. Okay, now before we get started with taking antiderivatives, we need to talk about one thing that's going to happen in that process. So if you'll take a look at these 4 equations, I want you to take the derivative of all 4, put them right here. Sorry, this guy isn't lined up. Looks so ugly. Okay, so 3x squared. What's the derivative? Okay, next one. 3x squared plus 4. What's the derivative? 6x. Okay, next one. 3x squared minus 5. What's the derivative? 6x. And then 3x squared plus, let's say, e. What's the derivative? 6x. So the problem is that all of these equations, were they the same? No, but they all yielded the same derivative. So now when we go backwards, we're going to have to deal with that. So when you take an antiderivative, remember that when you take the derivative, that constant always goes away. So when you're trying to go backwards, you don't know what that constant was before you took the derivative. So we're going to use a general solution using an ambiguous constant when we go backwards. We're going to call that the constant of integration. And basically, you're just going to put a plus C, where C is standing in for whatever this very last little constant thing would have been before you took the derivative and it fell off. Okay? So for the example that we just did, if I have a 6x and I want to go backwards, what's the antiderivative of 6x? It'd be 3x squared, but then you would put plus c, where that c is going to essentially represent whatever this constant was at the end that I would have lost in the derivative process, that then going backwards, I can't get it back. Okay? So let's run through the power rule. When I take a derivative, let's just discuss. You take the number at the top, you times it down to the front, yeah? Then you take away 1. That's how we take a derivative. Everyone good with that? So we're going to reverse that. To do an antiderivative, you're going to add 1 to the power. And then whatever that new power is, you're going to divide that new power in the front. So for example, if my equation was x to the n, okay, right here, I would increase my power by 1. So x is going to be to the n plus 1. And then whatever that new power is, the n plus 1, I would divide that into the front. So now it would be 1 over n plus 1. Okay? So let's work an example. Let's do this one right here. We're going to go one term at a time. Remember, all you're doing is you're going to add 1 to the power, then divide that new power in what's in front. So if I have a 12x3, what is my x3 going to go to if I power it up? X4, and then I'm going to take that 4 and I'm going to divide it on the number that was already in the front. So 4 divided onto the 12, what's my new coefficient? 3. Next term, I have a 15x squared. I'm going to power the x squared up. What's it going to be now? X to the 3. Then I'm going to divide that 3 on the 15 in the front. Plus 5. Okay, next one is an 8x. When I power my x up, it's going to go to a what? X squared. And then I'm going to take that squared, divide it on the 8. 8 divided by 2 is a 4. Don't forget, plus c. Remember, that c is standing in for whatever constant would have been there before you took the derivative. Now, if you ever want to check your work, take the derivative, see if it matches what you started with. Okay, so if I take the derivative, that'd be 12x cubed, check, 15x squared, 8x, and then whatever the constant is, it would have gone to 0, which is why it's not represented in the original. Good? Turn the page. Okay, next example, we have a 18x squared minus 8x plus 3. Okay, let's start with our antiderivative. Remember, we're going to add 1, then divide. Okay, what will the first term be when I add 1 to the power? X to the 3. And then I'm going to divide the 3 on the 18. What's that number going to be now? 6. Next one is an 8x. My x is going to go to a what? Squared. And then I'm going to divide the 2 onto the 8. What's that number now? 4. Very good. Now you'll notice that the 3 does not have an x, so we're going to call that 3x to the 0. Then when I power its x from 0 to 1, now it's an x to the 1. And then I would divide the 1 on the 3, and it would stay a 3. So essentially, if you ever have a number by itself, you're just going to put an x with it, okay? Versus if I take the derivative of a number by itself, remember it goes to 0. So now that we're going the opposite way, the antiderivative of a number, you'll give it its x back, okay? Then plus c, and you're done. Okay, next one right next to that. I have an x3 antiderivative. What will it go to? X to the 4, and then put a 1/4 in front. So if there's not a number written in front of the x, it counts as a 1, divided by whatever you need to go there. Okay, my next one is a minus 12x2. My x2 is going to go up to an x3. Then I'll divide the 3 on the 12. What will that give me? 4. Next one, I have a 1/2 x. My x is going to power up to a what? X squared. And then I have to divide by 2 on a half. What is a half divided by 2? A 4th. Then I have a plus 5. What's that going to go to? 5x. Remember, it's just going to get its x back, and then plus c. Okay, where remember that your c is standing in for whatever constant might have been there that when you took the derivative got lost. Okay, next one, take a look at number 3. Number 3, I have x's on the bottom. What do? Negative exponent. Very good. So on example 3, I want you to rewrite using negative exponents for any x's that are in the denominator. Okay, there is no quotient rule for antiderivatives. There's no product rule for antiderivatives. So if you get a fraction, you need to make it not a fraction anymore by rewriting it. Okay, so my rewrite here would be 3, and then my x to the 4 is going to come up as an x to the minus 4. Let's see. Minus my 6, my x squared is going to come up. Now it's an x negative squared. And then plus a 5x3 still. Now notice I haven't actually taken the antiderivative. All I've done so far is rewrite it. Okay, from here, what happens? Don't forget your little dx at the end. Okay, this basically means the integral with respect to x. So you're only actually taking the antiderivative of this middle part. Okay, so most of your questions on your homework will have like a big parentheses. Think of this kind of like a sandwich. Integral with respect to x. Okay, so let's start with x negative 4. Add 1. What do you get? Negative 3. And then I would take that negative 3 and divide it on the 3 in front. Negative 1. Next one, I have x to the negative 2. Add 1 to that. What do you get? X to the negative 1, but then I have to divide the negative 1 onto the negative 6. Plus 6. Very good. Okay, last one. My x is to the 3. I'm going to up that to x4. And then divide the 4 on the 5. It would be 5/4. Don't forget plus c. Okay, for your delta math, that will be good enough. But for the AP test, they're not going to leave those negative exponents. So, for example, on that first one, if it's a minus 1x to the negative 3, you would just drop that back down. So it'd be over x3. And then same thing for the second one. If it's a 6x to the negative 1, that's a 6 over x. And then a 5/4 x4 plus c. Okay. But for your delta math, that first one is fine. It's really just more AP style questions. They wouldn't let you leave it like that. Okay. All right. Go ahead and take a look at number 5. Okay, remember what I said, no quotient rule. So if I've got X's on the bottom, I need to find a way to rewrite that so that I don't have X's on the bottom anymore. So you're essentially gonna simplify by dividing X squared out of each term. Now, here's what I mean by that. If you have an 18x to the 5th and you divide it by an x squared, how many x's will stay with your 18? 18x3, very good. Okay, next term, it was a 5x cubed, but I'm dividing x squared out of it. What would be left? 5x. Now, for my 9x squared, if I divide the x squared out, what's the only thing left? Just the 9. And then for my 3, if I divide it by x squared, that would be 3x negative squared. Okay, and think about why. For the 3, it doesn't have any x's to cancel out the ones on the bottom, so I would just pull them up to the top using a negative. And then from there, take the antiderivative using the same rules. So remember, we're going to add 1, then divide. Start with x3. What's it going to go to? x4. Then divide the 4 on the 18. Okay, I'll come back and reduce that later. My next one is a 5x. When I power the x up, it'll go to a what? 2, and then 5 over 2. My 9 is by itself. What's the antiderivative of 9? Just give it its x back. And then for my 3x to the negative 2, if I add 1, what's the new power? Negative 1, and then divide that on the 3. Now it's a minus 3 plus c. Okay, now for delta math, that would almost be good enough, but it would not let you leave the 18 over 4. So 18 over 4 can both divide by what? 2. So it'd go to 9 halves x4, 5 halves x squared, 9x. And then when I get to the x to the negative 1, I'll just push that back down. So it'll be minus 3 over x plus c. Okay. All right, take a look at number 6, please, right next to it. Okay, what rewrite strategy did we use for square roots when we were doing derivatives? What did we change the square root to? Good, 1/2. So remember that a square root is the same as a 1/2 when you do your rewrites. So my rewrite on this one, RW for rewrite, would be 8x to the 1/2. And then when I get to the 10, it's the square root of x cubed. So I would still let the x be to the 3, but then for the root, I would cut it in half. So it'd be 3 halves. And then the plus 5 is the same. Questions on that? Okay, go ahead and take the antiderivative of that. Remember, we want to add 1 and we want to do it as a whole fraction. So if I'm measuring these in halves, I want to add 2 halves. What is 1/2 plus 2 halves? X to the 3 halves. Okay, now be careful on this. We want to divide by 3 halves. Then what are we going to multiply by? 2/3 is correct. So I do 1/2 plus 2 halves is 3 halves. Then I'm going to put a 2/3 in the front, and that's going to multiply with the 8 that was already there. Okay, we'll come back and do that in a second. Next one, I have a 3 halves. I need to add 1 to that, so I'm going to add 2 halves. What's 3 halves plus 2 halves? x to the 5/2. And then if I have to divide by 5/2, I'm going to multiply by 2/5. And there was already a 10 in front, so my 2/5 will combine with that. Okay, and then for my 5 will go back to a what? 5x. Very good. Plus. Okay, then for your fractions, remember, times the tops and the bottoms together. If you have a number like 8 that's not in a fraction, it counts as on top because it's over 1. So this would be 8 times 2 is 16. I cannot divide that by 3, so I leave it as 16 thirds. Okay, then remember in your little fraction on the top number is the power, the bottom number is the root. So it should be x3. And then the 2 on the bottom means it's in a square root. No, I think I would have seen them if they were left in here. Sorry. Okay, then next one. I have 10 times 2. What's that? And will that divide by 5? 20 divided by 5 would give me a 4. And then my x is going to be the top number's the power, the bottom number's the root. So this is x to the power of 5 and under a square root. And then my 5x plus c is the same. Questions on that? Okay. And then delta math will let you leave it like this, but you don't have to switch it to the radicals, but you would have to make sure your number in the front is like a whole number, not like an 8 times 2/3. All right, turn the page. You have a cubic root example next. So if a square root changes to a half, what will a cubic root change to? A third. Very good. Okay. So if I'm doing my rewrite on this, let me give you actually a second to try it on your own. Okay, so do your rewrite. Let's see what you can do. Yeah, you always put your computer right, please. Okay, so if they're cubic roots, you're going to use a third as your power. And then when you add, you'll add 3/3. Because remember, the third
He's
still
convinced
stays
that it's
on the
not a machine. He makes me change.
Yeah. A lot of first period finished. I don't remember exactly. Just reset it. Yeah, as soon as we finish the notice and I turn off the video, then.
No. Showing on defense behind cut water.
No, I just never wear them. I've been kind of sick.
I'm there.
And I brought them back for me to switch into them. All right, now let's do the antiderivative. So what are we adding? If it's a 1/3, we want to add 1, so we're going to add
2/3.
3/3. Because you want to add 1 whole fraction, right? So do plus 3/3. And then what's 1/3 plus 3/3? And then when you get the 4/3 to divide by that, you'll times by a 3/4 with whatever the number was that's in the front.
You say 3/4 and 4/3.
So it's a 4/3 up top, but then if you're dividing by 4/3, you're gonna put a 3/4 there. Okay, so for your first one, it's gonna be 7. And then for your cubic root, so you're gonna do x to the 3rd.
I didn't think about that.
And then plus six. Now your x is squared,
Oh.
so it would be to the two. And then for this one, it is 12. And then your x is the cubic root, but if it's on the bottom, you'll still use the 1/3, but you'll turn it to negative 1. To be minus 12x, if it's the minus 1/3. Mama, you've got your next figure. Okay, and then y'all, when you're adding, you wanna add your 1 will be a 3. Because you need it to match the fraction type that you have. Yes. Yeah. Don't forget plus C. Yeah. So if you want to bring the cubic root up from the bottom, you're going to use a negative. So if it's a cubic root, it's a 1/3. So you'll do x to the minus 1/3, and then don't forget the minus 12. It'll be minus 12x to the minus 12. And then when you're adding this, you can call it the whole fraction. Not 2/2, but 3. Yeah, and then why did that? Was this after you've done it? So hold on, what's negative 1/3 plus 3/3?
I think it's good length right now.
Okay, let's put that away. Wait, did you get in? It says you're admitted.
Does that mean it's really?
Okay. Take the seat. All right, let's see how you did. Okay, you should have 7. Okay, cubic root x is x to the 3rd. 6 cubic root x squared is 6x to the 2/3. And then for your last one, okay, if you want to pull your cubic root x up from the bottom, it would be x to the minus 1/3. Okay, from there, you haven't taken the antiderivative yet. All you've done is rewrite it so that you can do power rule. Okay, from here, let's go one term at a time. Okay, let's stay focused. We're almost done. Okay, you're going to add 3/3 to 1/3. What are you going to get? 4/3. And then to divide by 4/3, what are you going to put in the front? 3/4 times the 7 that was already there. Okay, there are a lot of these on your homework, so I want to make sure we have good examples in your notes to look at. Okay, next term is a 2/3. I'm going to add 3/3. What am I going to get? 5/3. But then to divide by 5/3, I'm going to times by what on the 6? A 3/5. Then when I get to the last one, it's a negative 1/3. If I add 3/3, what do I get? 2/3. And then to divide by 2/3, I need to times the minus 12 by a 3/2 plus C. Okay, then from there, remember the numbers in the front count as multiplying into the top unless it's a fraction already. So 7 times 3 here is a 21/4. Then remember the top number is the power. So 4th power, and the 3rd is the type of root. 6 times 3 here is an 18/5. And then x is to the power of 5 and in a cubic root. Okay, for this one, remember you can choose the order. You can do 12 times 3 and divide by 2. Or you could divide the 12 and the 2, which gives you 6 times by 3, and you get 18. Power of 2, cubic root there, plus C. Okie dokie. Okay. There is one question that we skipped that I want you to go back to it because you'll get one like it on your homework. So turn back one page. Let's do the one with parentheses. I'd say 10 minutes from being done. We're 10 minutes left. Ish.
Right.
Almost there.
So I have a question. Whenever you write, are you
Yep.
supposed to put the exponent like inside the square root? Or?
It actually doesn't matter. They're the same.
Okay.
So I usually write it on the outside, but you can put it on the inside. All right, take a look at number 4.
Who's the starter?
All right, number 4. Okay, you do not have a product rule for antiderivatives. So the only way for you to take the antiderivative of this is to make it not a product anymore. So you're going to have to multiply it out. Okay, and you should know how to do that. But you're going to multiply it out before you take the antiderivative. So what I mean by that is you're just going to like FOIL it or double distribute it or whatever you want to call it. So what is 3x times 2x squared? 6x to the third or cubed. Very good. Okay, then 3x times 1 would just be a plus 3x. Because anything times 1 stays the same. Okay, then my minus 7 times 2x squared will go to a 14x squared. And then 7 times 1 would just make that a minus 7. Now, if any of these can combine like terms, do it. In this case, they won't, but on your homework, they could. Okay, from there, we're ready to do the antiderivative. So starting with the 6x cubed, what would the antiderivative of that be? X4, and then what would the front number be? 6/4, which can reduce 3/2. Very good. Okay, next term is a 3x antiderivative. What would it be? 3/2 x squared. Okay, think about the next term. What would it be? 14/3x3, and then the minus 7 goes to a minus 7x plus c. Okay, if you leave off the c, it will kind of wrong. All right, last thing we have to cover is all of the trig rules that you already know, but you're just doing them backwards. So if you'll turn to that last little page there, we're about to be done with notes. We're just finishing out these last 4 right here, and then we're stopping for today. Okay, snow cone, snow cone. Okay, remember that for derivatives, you're going to go down the snow cone list. Then for antiderivatives, you're just going to go up the snow cone list. So for example, if I want the integral of cosine x, you're going up that list. Where would you end up? So if I'm on cosine and I go up, that would put me on sine x. Okay, don't forget, technically plus c. Let's say that I want the integral of sine x. And I'm already at the very top of the list, then where do I loop back to if I want to go up? Back around to the bottom, which would be negative cosine x. Okay, does anyone happen to remember the derivative of tangent? Secant squared. Then the antiderivative of secant squared would bring you back to tan x. So remember that all of the derivative rules that you already know are the same thing backwards. That if tan, the derivative is secant squared, then the antiderivative of secant squared would bring you back to tan. Okay, same thing for E and ln. what was the derivative of e to the x? Then what's the antiderivative of e to the x? Still e to the x, but plus c, because remember, you don't know when you took the derivative. Maybe there was a constant attached, but when you take the derivative, those go away. So then going backwards, you have to leave a little space for your plus c. Does anyone remember the derivative of ln x? 1 over x. Then when I go backwards, if I see a 1 over x and I'm anti-derivatizing it, then I would put ln x. Okay, technically, you do need absolute value bars around that. Okay, when you do an ln, you need to bar your x. So we have 4 examples left, then we're done with notes. Okay, take a look at number 8. 6x squared plus 9 sine x plus pi. Start with the 6x squared. What's the antiderivative of that? X cubed. And then in front, it is a 2. Make sure you divide by the new power. So when I up this to an x3, I'm dividing by 3 on the 6 to get the 2. Okay, next one is a positive 9 sine. If I'm already at positive sine, where do I end up? Negative 9 cosine. Then remember that pi is just a constant. What's the antiderivative of plus pi? Pi x. Okay, and you're done. Okay, go right below that. We have an 8x. What's the antiderivative of 8x? 4x squared. Next one is a minus 2 cosine x. So if I'm on minus cosine on my snow cone, and I go up 1, what do I end up on? Negative 2 sine x. Okay, then I get to my secant squared. What's the antiderivative of secant squared? Tan x plus c.
The negative sign, would the -2 and the negative sign as well, or would it just be the?
No, because we're using this negative when we check our chart. It's not like a separate negative to cancel out. Good question. Okay, number 10, I have a 6 e to the x plus 7 cosine x minus 2. What's the antiderivative of 6 e to the x? Okay, 6 e to the x. Then we get to 7 cosine x. What's the antiderivative of that? 7 sine x. Still positive because you went up a rung when you're doing an antiderivative. Then minus 2 goes to what? 2x. And then plus c. Okay, last one. If you have a 5 over x, I want you to rewrite that. That is the same as 5 times 1 over x. That way it'll make it more obvious that when I take the antiderivative of 1 over x, what do we know we go back to? ln, very good, natural log. So it would be 5 ln x plus, and then what's the antiderivative of the 4? And then plus c. Very good. Okay, also remember, technically, your ln does need to be in bars for it to be correct. Okay? Can you do it? Good. Do your homework. Don't use the rest of your packet as scratch paper. We're going to finish it next time. You can use the blank sheet, yeah.